the wavelength of ultrasonic waves in our equation. To calculate the wavelength of pulse, we have an equation that is lambda is equal to V upon F. Here lambda represents the wavelength of that pulse. In the same manner, F represents the frequency of that pulse and V represents the velocity of ultrasonic waves in water. Here, by keeping the values of V, that is 1800 meter per second, in denominator F, that is 10 raised to 6 hertz. It was actually 1 megahertz, we converted it into hertz, that is 10 raised to 6 hertz. By substituting these values in this equation, we can just calculate the wavelength of pulse, that is lambda is equal to 0.0018 meter. So from this equation, d is equal to Vt by 2 and lambda is equal to V by F, we can calculate the depth of the sea and in the same manner wavelength of the pulse. We can also see it in presentation that depth of the sea, that is d is equal to Vt by 2. We can calculate the depth of the sea by d is equal to Vt by 2, and in the same manner wavelength of pulse can be calculated by lambda is equal to V upon F. Let us move forward to calculate the again next numerical. This is also a question which is frequently asked in the exam. This question is related to fiber optics. In fiber optics, let us read the question. An optical fiber having core and its cladding have refractive index of 1.545 and 1.495 respectively. Here 1.545 is the refractive indexes of core and 1.495 is the refractive index of cladding. Calculate the critical angle. Here we are asked to calculate the critical angle, that is 5C, to calculate the acceptance angle, that is 5 in maximum, and to calculate the numerical aperture, that is NA. So we have to calculate critical angle, acceptance angle and numerical aperture. So let us calculate with its solution. Here you can see that this eta 1 represents the value of 1.545. This value of 1.545 represents the refractive index of core. Eta 2 represents the value of 1.495, that is the refractive index of cladding. The thing which we want to calculate is critical angle, that is 5C. 5 in maximum represents the acceptance angle and NA, that is the numerical aperture. From the Snell's law, we have derived the equation 5C is equal to sine inverse into eta 2 by eta 1. So from this equation, we can calculate the critical angle. By substituting the values of eta 2 and eta 1, we can just get the value of 5C. 1.495 is the value of eta 2 and 1.545 in denominator is the value of eta 1, that is the refractive index of core. By dividing this term and getting the sine inverse of that term, we can obtain the value of angle which is called the critical angle. We have here obtained the value of critical angle is 75 degree and 23 minutes. So now let us calculate the acceptance angle. In the same manner, let us calculate the acceptance angle. Acceptance angle 5C, 5 in maximum, is equal to sine inverse under root eta 1 square minus eta 2 square. Actually, if here sine inverse is on right hand side, if it is on left hand side, the equation would be like sine phi in maximum will be equal to under root eta 1 square minus eta 2 square. I repeat, if the sine inverse here on the right hand side is on left hand side, then the equation would be like sine phi in maximum will be equal to under root eta 1 square minus eta 2 square. Now here we just want to obtain the value of acceptance angle, which is phi in maximum. This in represents the angle of incidence. Phi in represents the value of angle of incidence, and maximum represents the what is the magnitude or the value of maximum incidence angle through which we can get the angle of critical at the core and cladding interface. While substituting the value of eta 1 and eta 2, that is 1.545 square minus 1.49 square, and doing the under root, we can obtain the value of it, that is 0.3898. 5 in maximum, we can get the value is 22 degrees and 56 minutes. So through this equation, that is 5 in maximum is equal to sine inverse under root eta 1 square minus eta 2 square, we can calculate the acceptance angle. With that, let us calculate the numerical aperture. Here, numerical aperture is actually the figure of merit which describes the maximum angle. It describes the maximum angle, that is numerical aperture is equal to sine phi in maximum. That means this is also a maximum angle, hence numerical aperture will be equal to sine phi in maximum. We have to just substitute the values of phi in maximum and get the value of its sine. By substituting this value and obtaining the sine of that value, you can obtain the value of numerical aperture, that is 0.3896. So in this manner we have calculated the critical angle, in the same manner acceptance angle, and in the same manner numerical aperture. We can just also represent it. Equation of fiber optics, that is critical angle phi c is equal to sine inverse eta 2 upon eta 1. This three equations of critical angle, acceptance angle and numerical aperture is obtained with the help of Snell's law. Through Snell's law, you can just not only derive but also calculate the values of critical angle, acceptance angle and numerical aperture. Phi c is equal to sine inverse eta 2 upon eta 1 represents the critical angle. Phi in maximum is equal to sine inverse under root eta 1 square minus eta 2 square represents the acceptance angle, and numerical aperture NA is equal to sine inverse phi in maximum. Okay, let us go to the next numerical, that is calculate the electrical conductivity of copper. To calculate the electrical conductivity of copper, we have given the atomic weight, we have given its atomic weight, density, relaxation time as below, that are 63.5 is the atomic weight, 8.9 into 10 raised to 3 is kg meter inverse cube, that is density, mass per unit volume, and 2.48 into 10 raised to minus 14 second, that is the relaxation time. So here we need to calculate the electrical conductivity. Let us calculate the electrical conductivity and just read the solution of this numerical. We can see that atomic weight is given, that is 63.5. Atomic weight is given of 63.5. In the same manner, density D is represented by the value 8.9 into 10 raised to 3 kg meter inverse cube, and in the same manner tau, this tau represents the relaxation time, that is equal to 2.48 into 10 raised to minus 14 second. To calculate the conductivity can be represented in sigma is equal to n E square tau upon m. Here in this equation, sigma is equal to n E square tau upon m sigma represents the conductivity, electrical conductivity. In the same manner, n represents the number of electron per unit volume, that is density of electron. I repeat, n represents the density of electron, that is the number of electrons per unit volume. E represents the magnitude of charge, that is 1.6 into 10 raised to minus 19, and in the same manner tau represents the relaxation time, and m represents the rest mass of an electron. Now we have the value of E, tau and m. The value of m is known, tau is known, and E is known, but here we don't have the value of density of electron. So to calculate the density of electron, we have a equation. Density of electron is equal to number of free electron multiplied by Avogadro number, n suffix a. Na is the Avogadro number multiplied by the density d divided by its atomic weight. By using this equation, you can calculate the density of electron, that is the number of electrons per unit volume. So you can see here the unit of that density of electron is meter inverse cube, that is electron per meter cube, number of electrons per meter cube, hence it is meter inverse cube. The unit to calculate the density of electron is meter inverse cube. Here for copper, the number of free electron is taken as 1. Avogadro number, that is 6.023 into 10 raised to 26 multiplied by d, that is 8.93 into 10 raised to 3 divided by 63.5. Through that we have obtained the value of density, that is 8.4 into 10 raised to 28 meter inverse cube. So by using this equation of density of electron, we obtained the value of density of electron, that is n, small n, which is equal to 8.47 into 10 raised to 28 meter inverse cube. So by obtaining the value of density of electron, we can substitute it in the equation of sigma is equal to n E square tau upon m. We have the value of m, tau, E. We calculated the value of n, that is the density of electron or number of electron per unit volume. So by substituting the value in this equation, you can see here to calculate the conductivity, here m is given, m is the rest mass of electron, that is 9.11 into 10 raised to minus 31 kg. Sigma is equal to n E square tau upon m. We have substituted the value of n, 1.6 into 10 raised to minus 19, that is E, tau, that is 2.48 into 10 raised to minus 14 divided by the rest mass, that is 9.11 into 10 raised to minus 31. By just calculating this term, we can obtain the value of sigma, that is electrical conductivity, which is 5.87 into 10 raised to 7 Siemen, S means Siemen, meter inverse, or the another unit to calculate the electrical conductivity is ohm inverse, meter inverse. So in this manner we have calculated the electrical conductivity of copper with the values of atomic weight, density, relaxation time and density of electron, that is the number of electron per unit volume. You can also see it on this. Electrical conductivity sigma is equal to n e square tau upon m. Actually small t is tau upon m. Okay. Let us move forward to short questions. Till now we have calculated as well as gone through the sums with their ready-made solutions. We also got to know about the equations and the chapters from which the numericals can be asked, or it was asked in January 2013, in the exam of January 2013. Let us go to the answer in short. The first question which was asked during the exam was define reverberation time. Reverberation time, the definition of it you can write is the time taken by the sound to fall below the minimum audibility level, or you can also write it according to Sabine, that is the time taken by the sound intensity to fall to 1/1,000,000th of its original intensity after the source stopped emitting sound. This was the answer, or this was the two answers which you can write in or, that is you have an option, or if it is asked in the manner of Sabine, define the reverberation time according to Sabine, you can write time taken by the sound to fall, sound intensity to fall to 1/1,000,000th of its original intensity after the source stopped emitting sound. Now let us move towards the next definition which is asked. Actually this is not a definition but the factors. This is the question which is frequently asked in short questions as well